Hi, my name is Glynn Foster and I'm a product manager in the Oracle Solaris Core Technologies group. In this video, we're actually going to look at some of the transitioning information that you need going from Oracle Solaris 10 across to some of the new features included in Oracle Solaris 11. This is a three-part series. In this part, we're going to cover the lifecycle management technologies. One of the fundamental things we've been doing in Oracle Solaris development, particularly since Oracle Solaris 10, is really trying to modernize the operating system, trying to include technologies that are really well integrated together across operating system, virtualization, software-defined networking, and through to the cloud with OpenStack. Really focusing on how do we help our administrators and our customers in our data centers today to be more agile and move their environments toward cloud-like in nature. So let's look at some of the things included in the new lifecycle management aspects of Oracle Solaris 11. If we look at lifecycle management, we really want to make sure that we can be a little bit more efficient, a little bit more automated with how we update and install software on an operating system level. What are the key drivers in the enterprise? Well, we want to try and ensure that we can reduce system downtime, make patching much easier, make sure that when customers, administrators need to apply security fixes, they can do that very, very fast and get up and running as fast as possible. In particular, with virtualization being so apparent now, there's a lot of more constraints on how often you can take maintenance windows and take that system down. How do we simplify the administration of that, by the software and the hardware firmware? And how do we do this in a really sort of strict environment where we really have a lot of compliance regulations that we need to comply with? How do we ensure that the latest updates are always applied? Some of the challenges from an administration point of view is they're often asked to do more with less resources, particularly when you look at the sort of virtualized and physical environment sprawl in today's modern data centers, where you've got multiple versions of hardware, multiple platform versions, database versions, OS versions, application software. It's really hard to manage. How do you do that at scale in a more simplified, automated way? How do we shift towards multi-tenanted clouds where, again, it's hard to schedule maintenance? How do we ensure that we're always complying against compliance regulations and ensuring that security patches are applied in a timely fashion? So let's look at some of the changes between Oracle Solaris 10 and Oracle Solaris 11. Now, we've replaced a lot of the core provisioning and software management infrastructure and technologies in Oracle Solaris 11 to be more automated, more integrated, and really sort of best position people to start moving their environments towards the cloud. SRUS packaging and patching in Oracle Solaris 10 has been replaced with the image packaging system, a new network-based package management system. Some of the legacy DVD installation mechanisms in Oracle Solaris 10 have been replaced with more lighter weight installation, offering live DVD experience to be able to boot a system up in memory and evaluate it, through to a simple text-based interactive installer, really specially designed for server-based environments. We've replaced live upgrade with a concept called boot environments. Boot environments take advantage of ZFS, and we'll cover them. One of the big changes, we've replaced the JumpStart system to be able to provision multiple systems automatically without any administrative overhead with automated installer. We'll cover that in this video. Also, flash archives, where you can be able to capture a system image for cloning or disaster recovery. We've introduced unified archives in Oracle Solaris 11. We'll cover those. And also being able to create your own customized installation media. We've introduced the distribution constructor, something that we really didn't provide any functionality before in Oracle Solaris 11. So why build a new installation framework? Well, I think we really needed to adapt quite considerably. JumpStart was written a long time ago and really wasn't well integrated with some of the new technologies that we've introduced in Oracle Solaris over the years. Things like the ZFS file system, Oracle Solaris zones for OS virtualization, SMF for service management facility for service start and restart. How do we provide a system that's simple to set up, simple to maintain, is automated and as predictable as possible? How do we deeply integrate with virtualization technologies to make installing those much easier? And how do we optimize for moving to be more agile in an enterprise cloud environment? Easy installation of both physical systems and also virtual systems, and fast replication of those environments, especially when you want to do that at scale. So in Oracle Solaris 11, we took a look at all the technologies of installation and provisioning and started to replace them, thinking about, how can we more modernize these to cope with some of the modern demands of the data center, different network topologies, different protocols, that sort of stuff. In Oracle Solaris 11, we've replaced some of the media to be smaller in size, to be a fixed sort of software configuration that you install. You rapidly install a system, and then after that you've got to a state where you can actually go and get more software as you need it, rather than having to install 2, 3, 4 DVDs of software that you'll have to try and remove afterwards. So we've created different media, from live DVD and live USB for evaluation purposes to a text installer for a server-based profile install. The automated installer is now a simplified installation over the network, very similar to JumpStart, but takes advantage of some of the unique features like Oracle Solaris zones to be able to provision virtualized environments at install time. It's fully integrated with the image packaging system, the new packaging system that I'll talk a little bit later. It provides a more modern approach to networks that's WAN capable and provides end-to-end security from that initial time when your system boots off the network, contacts a server to install, and installs those bits. And we also provide bootable media as well for completely isolated installs as well. We recognize there's a lot of customers in a very sort of security restricted environment where they can't get access to network. So we provide a customized way to be able to do that. So the automated installer is very similar in concept to do a JumpStart install. You'll boot a client system over the network, it'll contact a DHCP server, it'll get an IP address, a host name, and the address of the AI server, the automated install service. It'll then download a simple mini route to get up and running, and it'll contact and have a communication between the automated installer. There, the automated installer will essentially decide how it should go about installing that system based on an AI manifest and a system configuration profile. It'll match based on a number of criteria like MAC address or CPU or architecture. Once it's got that information about how it should install itself, the client system will contact a remote or locally connected IPS package repository and install software from that. The command lines in the automated installer have been simplified substantially. There are a few main ones that you need to consider. Install ADM is how you create a new install server, how to create new services within that server, how to assign different manifests and profiles to that server. System configuration is done through SMF, through automated installer, and the sysconfig command allows you to be able to create and apply and unapply system configuration. It's a very nice interactive text-based graphical way to be able to do that. AI manifest is a command line utility to allow you to dynamically change the contents of an AI manifest. We'll cover that a little bit later. We've also introduced a new web-based wizard to be able to easily create manifests. But if you're moving over from a JumpStart environment, you'll likely be interested in this command line, the JS to AI command. And this helps you migrate JumpStart profiles and rules across to the equivalent in the automated installer. It won't do everything, but it'll certainly get your base configuration across and you get up and running as fast as possible. So I've mentioned the SMF configuration provides system configuration. SMF was first introduced in Oracle Solaris10, and you might have used it to be able to configure system services. Well, we take advantage of the SMF configuration repository to be able to apply configuration to that system. Such configuration might include user accounts, time zone, locale, hostname, through to networking, whether it's a static network or a DHCP, dynamic. We've also introduced Puppet in Oracle Solaris 11 to really provide automated configuration management. So any sort of application that doesn't take advantage of SMF right now is you can actually apply that application configuration through Puppet. Puppet is a very popular piece of open source software from Puppet Labs that provides configuration enforcement. It operates in a master agent architecture, so it's very, very scalable to today's modern data centers, particularly when you've got so many physical and virtualized systems. But we haven't just taken Puppet and included it into our package repository. We've actually done a lot of work to integrate it into some of the core technologies of Oracle Solaris, in particular writing Puppet resources for IPS, SMF, networking, zones, and ZFS. So let's take a look at some of the comparisons between JumpStart and the automated installer. You can sort of see from this chart that it's a very, very similar set of things. I guess fundamentally, some of the big things to think about is the fact that the pre-install and post-install configuration scripting has been removed in automated installer. This was a very conscious decision during the development of automated installer, because depending on the order of when that script was run, you may have a completely different end result. So we really wanted to make it a little bit more reliable, a little bit more repeatable. Now you can still also do configuration scripting, but it happens after the initial installation is done through a series of post-install SMF services that you can easily create and associate with your clients. If we take a look at a typical JumpStart rule versus an automated installer criteria, it's a very similar mapping. For example, on the JumpStart side, we may have the K-Arch rule. On the automated installer side, the criteria, we have the Arch criteria. So you should be able to see a very common mapping. It will be very familiar. So let's look at an overall migration strategy for how you move from JumpStart across to the automated installer. Well, obviously, first you need to have a system that's installed in Oracle Solaris 11 so you can actually create an automated install service. Once you've got that, you need to have a look and see what rules and profiles that you've got in JumpStart and move them across to the AI manifest. You need to have a look at how your sysid config in your Oracle Solaris 10 environments maps to SMF profiles in the Oracle Solaris 11 world. And for both of those two, the JS2AI command line can certainly help you with some of that transition. Then you need to create individual services for different clients through AI. Now, particular services might be a service for Oracle Solaris 11.2, a service for Oracle Solaris 11.3, or maybe you might map that to a more sort of organizational boundary. Maybe a set of clients, a set of systems that are specifically installed for a particular department or group. Then you need to consider if you've got any finished scripts. And my advice for that is to really take a look at what they actually do, because there's some things that they do you won't actually need to do in the automated installer world. We've actually taken and automated that. And a good example is the ability to provision zones out of the box. That's now included in an automated installer, so you won't need those scripts to have to do that. But some of those scripts might need to be converted to first boot SMF services. Those would typically be included in an IPS package that you publish to a repository, and you include that package as part of your installation profile. So have a think about how you might be able to transition to that and simplify your provisioning system. We've covered derived manifest through the AI manifest command, and that essentially allows you to be able to reduce the number of static AI manifests. For example, not have a manifest for each client system that may only differ in maybe one or two little configurations. It allows to be able to dynamically generate or edit through a scripting mechanism to be able to modify that AI manifest on the fly. The Automated Installer Interactive Wizard is a new service that you can start up, which is a web-based interface to allow you to easily create automated installer manifests. Now, if you've got access to the AI server, it can automatically save that resulting manifest directly to the AI server and really use it as a basis for more complex configurations. So get a base profile in place, a base AI manifest in place, and then do your customizations after that. It really provides a very simple interface, as you can see in these two screens. Sort of steps you through your Z-pool configuration, your ZFS data sets, what IPS publisher, what sort of packages you want to install onto that system. So it's a really nice way of getting up and running really fast. The distribution constructor is a new tool that didn't have a really equivalent in the Oracle Solaris10 environment. It allows you to be able to create customized installation images. You can interactively create text-based installers, or bootable AI, or even a live DVD. And it really leverages ZFS Snapshot for checkpoint and resume, because it's quite a slow process to be able to create a full piece of media. And where you'd use this is in a disconnected system that's not attached to the network in any way, where you really need to be able to install everything that you need on that system. So you need to create a customized installation media. Unified archives are a new feature that we introduced in Oracle Solaris 11.2 that replace flash archives. Now, unified archives allow you the ability to be able to create a complete snapshot and archive of a live running system. You don't need to take the system down in any sort of way. And it provides both cloning and disaster recovery. It takes advantage of bare metal and virtualized environments, so it covers bare metal, Oracle Solaris zones, Oracle VM for Spark. And it's a really great utility to be able to more seamlessly manage your sort of golden environments in the cloud. And that's really the foundation for image management and deployment at scale, particularly as you go through application templates. And it's certainly the strategy that we're taking for the Oracle VM templates, if you may be familiar with that. But they use the existing deployment mechanisms, and they're fully integrated. So there's two archive types. One's a clone archive, and the other's a recovery archive, and they have subtle differences. When you take a capture of a clone archive on a particular system, it'll only capture the current boot environment. We'll cover boot environments a little bit later. But it also system unconfigures the archive, so that it doesn't store any specific system configuration. And that means that it can easily deploy out to multiple nodes, multiple different virtualized environments. On the other side, the recovery archive takes a full snapshot of the entire system, all boot environments and all system configuration, so that if you're in a disaster recovery situation where you really need to restore the system, you can do so. Now, unified archives have a lot of different advantages. One of the unique advantages about unified archives is it actually captures the entire system, including the physical operating system and any virtualized environments or Oracle Solaris zones on top of that. That's really unique, so you can actually individually deploy particular parts of that unified archive. It also handles complete physical to virtual and virtual to virtual transforms. And that's really useful in this situation where you've got maybe developers working in a virtualized environment, maybe in an Oracle Solaris zones where they go through the development and test life cycles. You'd capture a unified archive. You take that archive, you maybe do some more testing, and you want to be able to lock down that unified archive as well. In Oracle Solaris 11, we've got this concept of read-only root file systems, or mutable global zones, mutable non-global zones, so you can completely restrict what that environment is, so you always know it has been unmodified. And this is in particular really, really good from a security point of view, but also a compliance point of view as well. So when you actually provision that environment to the cloud, you can always ensure it's exactly how you created. No one's had a chance to modify it on the way. And that's a much more seamless experience, because compliance in typical data centers is a very expensive operation to continually maintain and make sure that you meet the regulations required. So we've got a bunch of different resources available on the Oracle Technology Network. I'd encourage you to take a look. We've got everything from your typical white papers, screencasts, how-to articles, cheat sheets, videos, through to the product documentation itself to help you get it up and running. And we've got cover a wide variety of different areas, from setting up an AI server, to customizing it, to creating customized golden images, to be able to create unified archives for cloning or system recovery. And obviously, we've actually got a transitioning from Oracle Solaris 10 JumpStart to automated installer guide as well to help you. So let's move on to some of the packaging and patching mechanisms as part of that lifecycle management. So we were seeing an awful lot of time that administrators spent in Oracle Solaris 10 patching their systems, in particular as you know, the market trends move towards more sort of virtualization and consolidation. You know, administrators were managing multiple virtualized environments, and that perhaps wasn't as automated as it could be. So how can we make that more automated, make it easier to manage, reduce some of the complexity? In particular, one of the biggest causes of system downtime is actually human error, and up to 50% for planned and unplanned downtime is caused by human error. You know, how can we make that more automated? How do we get you out of the situation where you're patching a machine and you make a mistake? We want to try and avoid that, provide a more fail-safe system update. Fundamentally, we also wanted to create a system that was really integrated with the existing Oracle Solaris technologies. SVR4 packaging and the patching that was added on top of it wasn't very integrated either. So how do we really merge those two into a more seamless experience? How do we take advantage of those features that we didn't have when we were designing the system many, many years ago? So the image packaging system is a new network-based package management system that allows you to be able to install software from network-based package repositories. Now, those package repositories can be somewhere up in the cloud or locally within your data center or even on the machine themselves. It takes advantage of things like ZFS as the default root file system for providing safe system upgrade. It provides automatic package dependencies. So anyone familiar with using Linux or managing Linux-based systems, whether that's RPM and apt or dpackage and yum and all those sort of technologies, is, you know, how do we make that more seamless? How do we make it automated? How do we pull in the dependencies when you want to install a different package? And it's also uniquely integrated into Oracle Solaris zones. So now in an Oracle Solaris11 system, if you've got a number of non-global zones or kernel zones, it'll automatically update those zones in lockstep with a global zone, completely simplifying how you update a particular system. And it also understands system firmware as well. One of the things that we really wanted to try and understand is, you know, when we apply system firmware, sometimes it can actually break the operating system if the driver software is out of mismatch. So how can we automate that? How can we let people know when that's going to occur and prevent a system update? Boot environments are a really nice feature in Oracle Solaris 11 based on ZFS snapshot and cloning. They're incredibly storage efficient thanks to ZFS's ability to do copy and write file system. They're fast to create, they've zero cost, and they're 100% reliable, and it really enforces best practice around system update. So now when you do a system update, we'll create a cloned boot environment running your live production workloads. You can update an environment. It'll apply updates to that boot environment, particularly if there are kernel changes. Then when you've got a maintenance window, which we appreciate it's very hard to schedule, you can quickly reboot the system into that new boot environment and get up and running very, very fast. If for any reason that update breaks something, maybe your application is particularly sensitive to the system version software, you can simply reboot back into that older boot environment and get back up and running very, very quickly. And you know, ZFS boot environments can also be used for any administrative change as well. So if you're doing anything complicated, maybe you're trying to configure the network to do something in particular you're not quite familiar, you're a little bit concerned that you're going to break the system as a result of it, why not create a boot environment to have something to fall back on if something goes wrong? So this diagram shows the typical sort of life cycle around how you would apply a particular security update. Maybe you have a very, very small window, maybe an hour at 10 p.m. between 10 and 11. You actually can apply that update while you're running your mission critical loads. That update will create a new boot environment. It'll pull down whatever dependencies it needs to perform that update. It'll apply those changes to the boot environment, and you can get up and running very, very quickly. If something goes wrong for whatever reason, you can simply roll back to that previous boot environment in a matter of seconds, thanks to fast reboot. So let's take a look at a Rosetta Stone between Oracle Solaris 10 technologies and Oracle Solaris 11. Well, as you can see on the left-hand side of the slide, Oracle Solaris 10 really had separate commands for packaging and patching. It certainly wasn't very automated. And on the right-hand side, you can see a single set of commands using the pkg command. Now, it's got a bunch of different sub-commands for that, whether you're installing a particular package, whether you're updating a particular package, whether you want to find specific information about the package, what dependencies it has, what content it has, what version it is, some basic description about that. So it's very, very similar sort of set of command lines. Now with IPS, we also make a number of package repositories available for you to be able to download your software from. So we've got package repositories hosted from Oracle. Now we've got two package repositories. One's a release repository where we store the software that's available on particular release boundaries, such as Oracle Solaris 11.2, Oracle Solaris 11.3. And for supported customers, those who have an Oracle Premier Support contract, we also make a support repository available where we actually publish our updates. That's called the support repository. And to access that, you actually need an entitlement. So you go onto a website and generate a key and certificate based on your Oracle sign-on. You'll download that, you'll associate it to your clients, and you'll be able to install from there. Within the support train, we have a concept called support repository updates, where we actually update that support repository, or SRUs. They're issued on a monthly basis, and they're essentially consolidated updates of bug fixes that were leading up to that we publish to that. And those are simple to apply. You just do a package update, and they'll create a new boot environment for you and get up and running. Now the nice thing about IPS generally is that it provides an ability to be able to constrain the software versions on your system to a well-tested, well-known state. Now, unlike Oracle Solaris 10, it was very easy to sort of pick and choose what patches you wanted to apply, but that led to a typical scenario that you may have been running a configuration that wasn't very well tested. Now, IPS automates that. You simply just update to these monthly SRUs, you get all the fixes available, and you know that that has been well tested by Oracle. To help customers really align with their lifecycle management schedules, and we realize that performing updates on a monthly basis may be a little bit tricky, we actually align SRU releases to Oracle's quarterly critical patch update, or CPUs. So every third SRU is an official Oracle CPU, and these are cumulative security fixes. So if you can't, say, update your systems every month, maybe you want to align to one of these quarterly releases so you ensure that you've always got the security fixes that are available as best you can. And some great information on My Oracle Support to help you with this. For those customers that are experiencing bugs that may be pretty critical, we actually provide interim diagnostic reliefs, or IDRs, and these really help customers provide point fixes or relief for certain bugs, or help further diagnosis of critical issues. Now, unlike the SRUs and the CPUs that are delivered through a repository, these are actually delivered using standalone package archives. This allows it to be a little bit more flexible in terms of not having to update package repositories. We can actually deliver them directly as a single file. And the nice thing is you can apply these when a new SRU comes along that has included this fix, for example. Doing a package update will automatically back out this IDR and update to your latest SRU. And again, we've got some great documentation that covers this. But what we recognize for a lot of people is they'll have their own package repositories, and we provide a bunch of tools to be able to create your own package repositories. Now, why you might do this? Well, maybe you're in a network restricted environment where you need access to a local repository rather than going to Oracle's hosted package repositories. But also this provides better change control for your enterprise. So you can actually control what software packages are in your repository. Maybe you don't want to update to a newer release of Oracle Solaris 11.3. You don't want to allow our clients to do an accidental update to a newer release. Now you can easily sync directly from the Oracle hosted package repositories, or create a package repository from ISO downloads that you can get through My Oracle Support. And we've got tools to be able to do that and to easily mirror and create snapshots of those repositories. Again, we've got a great set of resources that are available to help you get up to speed with IPS. Again, we've got white papers, screencasts, how-to articles, videos, you name it, including all the product documentation to update systems, install your systems, to manage and create package repositories, and even for developers as well to be able to create their own packages and publish them into their own package repositories, and some great documents for that. Well, that's all we've covered for the lifecycle management piece. The provides really significant improvements in terms of the simplicity and automation of both installing your system and updating the software in it. We really encourage you to get up to speed in Oracle Solaris 11, start reducing some of your costs, and hopefully manage and reduce your system downtime. Thanks for watching. So the automated installer really works very similar to JumpStart. We've got a client system. It'll typically boot off the network and find a DHCP server. From there, it'll get basic information such as an IP, a host name, and fundamentally the address of the automated installer service. From there, the client will connect to the automated installer and download a mini boot image. It'll also do a match of how it should be installed. Now, the automated installer will have different installation profiles for different clients, typically. How they should be installed, what software, what system configuration should be applied, etc., etc. And that is all done, that matching is all done based on criteria. So if it's an x86 system or a Spark system, whether it has a particular MAC address, for example. Once it installs this profile, it'll connect to an IPS package repository where it'll actually install the software. So let's take a look at a typical deployment scenario. As we know, most developers will test in a virtualized environment. Let's say that they're doing the development test in an Oracle Solaris zone virtualized environment here. The great thing about how these sort of capabilities combine together, we take advantage of unified archives for golden image deployment. So this means our developer can go through their typical test and certification life cycles and create a golden image. Once they got to that image, they can choose to lock it down to make sure that it doesn't change between them doing that test and certification process to deployment. We create a unified archive of this image. The nice thing about unified archives is that it actually can be deployed with transforms. And what this means is an image that's created in a virtualized environment can actually deploy to a physical one. Or if it was created in a physical environment, it can be deployed to a virtualized environment. And even better, unified archives can do transforms across systems of the same architecture. So an example of that would be if our developers were, say, doing their work in an Oracle Solaris zone running on top of a T52 system, but we really wanted to scale up for a mission-critical production system, we'd actually could take that same environment and deploy to a bigger T54 system or an M-series system. Now, once we get to that environment, we want to be able to do a verification in terms of compliance. And the nice thing about a read-only environment using immutable global zones or non-global zones is we can really ensure that that image, that environment doesn't actually change at all. So it makes it much easier for our compliance audits that are so important in today's data centers.